So this is a rectangle that is 3 centimeters by, and the width is pretty even. Let me measure it at its widest, and it's 1.5 centimeters. Right, this is the widest point here. You're gonna go over some of these anyways eventually. So 3 by 1.5. Let's do it again. Yeah, and let me write it out so I don't forget. Left is 3 by 1.5. Right, so if you multiply these two together, you get 4.5 centimeters squared. And the right one is going to be how many centimeters squared? Okay, so pretend again it's a rectangle. Something, let's see, 2.5 on this side and 2.5 on this side. There is some loss area here you have to fill. So let's say the length is 2.5 and the width is, at its widest would be like around here maybe. This whole area is going to be filled, but I think that's sort of, this is like a small area here, so probably measure from here to here. Gives us 1.5 centimeters. So we'll calculate the area for that in centimeters squared, and then we'll proceed with the math in a second. The question is, how much of this pulp do I need to add to each spot to get an evenness of 0.12 millimeters, which is equivalent to this thickness of the wrap, right? And so the solution I made, it really looks like a solution almost, you know, everything looks like solubilized in the water because of the formation aid. Anyway, so if you have the solution information from last time, let me pull it out. I had taken 6 grams of abaca and I put it into 700 mils of water, right? And here you don't have the grams yet, so you have to figure out the grams first, right? How many grams of this, how many grams of this you need to add. So the way you do this, you have to go back to how much the wrap weighed. The wrap weighed 4.8 grams, and that had an area of 884 centimeters squared. And what we have on the left side, we have an area of 4.5 centimeters squared. So how much pulp does it take? So the right spot, sorry, the left spot is going to take, let me plug in the numbers, 4.8 multiplied by 4.5, and that's 21.6. That doesn't make sense. 4.5, oh, you have to divide it by 884. Okay, of course, Peter. All right, so 4.5 times 4.8 divided by 884. And that gives you 0.0 0.24 gram. All right, let's go back to the top now. You know that 6 grams went to 700 mils. Here we have 0.024 grams. So how many mils is this? Y. And Y is going to be, for the left, in milliliters, is going to be 0.024 times 700 divided by 6. Let's find out. So 0.024 times 700 equals 16.8 divided by 6. I will need 2.8 milliliters in the left part of the book, right, to give me, right, left part would be this. So 2.8 milliliters will have to go in here to give a consistent layer that is 0.12 mils in 0.12 millimeters in thickness. That is equivalent to the rest of the wrap. And again, hypothetical, right? 2.8 mils could be 3 mils. I mean, some of it will have to go around, right? We measured kind of generously to get the 2.8 mils. Probably less for the middle, and probably the rest will go around to support the leaf casting. So we know the left spot now. Let's do the right spot. Right spot. So this is, so I got the left here. Left, I need this much. Let's look at the right. So first calculate how many grams we need for the right spot. The length was 2.5, the width was 1.5, the area was 3.7 for the right. The amount of grams you need is going to be right, and this gave us 3.7 centimeters squared, and that is the x. X is 3.7 times 4.8 divided by 884. X for the right is 3.7 times 4.8 divided by 884, 0.02. 0.02 grams is needed. How many mils in my solution that translates to 0.02 grams of pulp? Well, again, you can go to your pulp. My pulp had 6 grams of abaca that I dissolved in 700 mils, from which I need 0.02 grams to go in that spot. How many mils is this? Right? So the y for the right side is going to be 0.02 times 700, 0.02 times 700 divided by 6. So 0.02 times 700 divided by 6 is 2.33, right? 2.3 mils. So the right spot needs to receive basically 2.3 mils of pulp slurry. And the left spot needs to receive 2.8 mils of slurry. All right, so let's try to do it and see where we get what we get.